Students, welcome to the channel. Our today's topic is the derivation of first equation of motion. Students, an equation that relates initial velocity, final velocity, acceleration and time is called an equation, first equation of motion. Students, there are two methods of deriving first equation of motion. One is called the graphical method and other is called the mathematical method. First, we will derive this equation of motion using graphical method. For this purpose, we consider the velocity time graph, in which the time is represented along x-axis or horizontal axis and velocity is represented along y-axis or vertical axis. Students, look at the graph. From graph, it is clear that the distance dB is equal to the distance dC plus CB. Further, from the velocity time graph, the slope of the line or slope of the graph gives the acceleration of the body. Here in this case, we get the slope by dividing the perpendicular or vertical with the horizontal. Now, vertical is the velocity, horizontal is the time. So, from the graph, when BC is divided by AC, we get AB. AB here represents the acceleration of the body. So, the slope becomes BC divided by AC equals to small a represents acceleration. So, BC divided by AC is the acceleration, and taking AC on the other side, we get BC is equals to A acceleration multiplied with AC. Since AC, from the graph, AC represents the time taken by the body. So, replacing AC with T, what we get BC is equals to AT. Students, further from the graph, it is clear that the distances OD or AC represents the time taken by this for this change of velocity, and BD represents the final velocity, where OA or CD represents the initial velocity. Replacing these values of BD, DC, CB in equation 1, we get the standard form of first equation of motion, that is VF equals to VI plus AT. Look, it relates final velocity with initial velocity, acceleration and time. Students, now let us derive the same relation using mathematical method. According to this method, first we will use the definition of acceleration. Let velocity of a body change from Vi to Vf during some time t. Then we represent this change of velocity that delta V equals to Vf minus Vi. Final velocity minus initial velocity will give us the change of velocity during certain time. You know, this change of velocity in a specific time is known as acceleration of the body. Therefore, by the definition, A equals to time rate of change of velocity, means when we divide change in velocity with the time taken, what we get? Acceleration of the body. Now, in this relation, we will put the value of delta B and we will get the equation for acceleration as A is equals to Vf minus Vi. What is it? Change in the velocity divided by T. T is the time taken for that change of velocity. Now we cross multiply this relation, taking T on the other side, we get relation like this. AT is equals to Vf minus Vi. Now we rearrange it to get the standard form of first equation of motion. That is again Vf equals to Vi plus AT. Students, thank you for seeing the video and joining the channel.